Welcome along. In this first outcome, we're going to get to know the parts of a small computer system, from the processor right through to the software, and see how they all pull together to get real work done. So what actually is a computer system? At its heart, it's hardware and software working together to take something in, process it, and give you a result, with storage keeping everything to hand. Think of the home PC on your desk. You type on the keyboard, the machine does its thinking, and words appear on the screen. Hold on to that simple pattern: input, process, output, and storage, because everything else in this unit slots neatly inside it. Most computers you'll meet follow what's called the von Neumann model, and it's simpler than the name suggests. You've got a processor, some main memory, and input and output, all joined by bundles of wires we call buses. The CPU pulls instructions and data out of memory, works on them, and sends the results back. The clever bit is that the program and the data live in the same memory, and that stored program idea is the foundation everything modern is built on. Let's meet the first few core components. The CPU is the processor, the brain of the machine, and you'll see names like Intel Core i5 on the box. The motherboard is the big circuit board everything plugs into, letting the parts talk to one another. And RAM is the fast temporary memory that holds whatever you're using right now, though it's wiped the moment you switch off. Now the next three. Storage, an SSD or HDD, is where your files and programs stay put even when the power's off. The GPU handles graphics, drawing everything you see on screen, and it might be built into the processor or sat on its own card. And the PSU, the power supply, quietly turns the mains electricity from the wall into the gentler voltages the components can actually use. If you take the side panel off a desktop tower, here's what you'd find. The motherboard holds the CPU socket, the RAM slots, and the expansion slots, with a chunky heatsink and fan sitting on top of the processor to keep it cool. Storage clips in by SATA cable or slot straight onto the board, and the graphics card drops into a PCIe slot. The PSU feeds power to it all, and the ports round the back are where your keyboard, monitor, and network cable plug in. Let's zoom in on the CPU itself, because it's doing something remarkable millions of times a second. Inside there's a control unit that directs the traffic, an arithmetic logic unit that does the sums and the comparisons, and a handful of tiny registers holding the data it's working on this very instant. The clock speed, measured in gigahertz, tells you how many of these cycles run each second, and having several cores means it can juggle a few jobs at once. That endless job the processor does has a name: the fetch decode execute cycle. First, it fetches the next instruction from RAM, then it decodes it to work out what's being asked and what data it needs. Next, it executes, actually doing the calculation or moving the data, and finally it stores any result before starting all over again. It's a tight little loop, but repeat it billions of times and you've got a working computer. It's worth pinning down the difference between RAM and ROM, because they sound similar but do very different jobs. RAM is your working memory, fast but volatile, so it forgets everything when the power goes, and it holds your open programs and files. ROM is read-only and non-volatile, keeping its contents without power, and it stores the startup firmware that wakes the machine up. So more RAM helps you run more at once, while ROM is quietly there every time you press the power button. Here, everything we've covered is gathered in one place. You can see the CPU processing instructions, the RAM holding running programs, the motherboard tying it together, storage keeping your files, the GPU drawing the graphics, and the PSU supplying power. A typical machine today might pair an Intel or AMD processor with 16 gigabytes of memory and a 512 gigabyte SSD. It's a handy table to picture when someone reels off a specification. Let's make this practical. Imagine a student opening up their desktop tower to give it an upgrade and needing to spot each part first. That big heatsink and fan in the middle are covering the CPU. The two long sticks beside it are the RAM, and a little card screwed flat to the board is the M.2 SSD holding Windows. The boxy unit with the mains lead is the PSU, and the card in the long slot is the graphics card. And once you can name them, ordering the right upgrade is easy. It helps to split the kit into two groups. Inside the case, you've got the internal parts, the CPU, RAM, motherboard, storage, GPU, and PSU, all wired directly in and generally left alone. Peripherals are the external bits you touch every day, the keyboard, mouse, monitor, and printer, plugging in through ports like USB and HDMI. The nice thing about peripherals is you can add, swap, or replace them whenever you like. Right, let's turn from the physical to the invisible, software. Software is simply the set of instructions, the programs, that tell the hardware what to do, and without it, the machine just sits there doing nothing useful. All of it falls into two broad families, systems software and application software. Getting that split clear in your head is exactly what this part of the outcome is after. Picture the system as a stack of layers. Right at the bottom sits the hardware, and right at the top sit you, the user. In between is the operating system, the system's software that manages the hardware, and above that, the applications you actually click on. Each layer politely asks the one below for help, so your app asks the operating system, and the operating system drives the hardware. So those two classes plus one extra worth knowing. Systems software runs and manages the computer itself, the operating system, utilities, and device drivers. Application software helps you get a real task done, your word processor, browser, or spreadsheet. And sitting underneath both is firmware, low-level code, baked onto a chip that gets the hardware going before the operating system even loads. Let's put the two side by side with some names you'll recognize. On the system side, you've got operating systems like Windows 11, Mac OS, or Linux, plus utilities such as antivirus and backup tools, and the drivers that let the machine talk to your printer. On the application side, there's the everyday stuff, Word and Excel, browsers like Chrome, and media apps and games. Systems software runs and protects the computer, while applications help you actually get things done. This table just lays those examples out neatly. Under Systems Software, you'll find operating systems, utilities, and device drivers, and under Applications, the productivity, internet, and media tools. So Windows and a printer driver are Systems Software, while Word and Spotify are applications. If you can sort a handful of programs into the right column, you've cracked it. The operating system really is the star of the system's software, so let's see what it juggles. It shares out the hardware, deciding who gets CPU time, memory, and storage, and it gives you the desktop, windows, and menus you point and click at. It looks after your files and folders, handles logins and permissions, and talks to your devices through their drivers. Without it, your applications simply couldn't share the machine safely. Here's a lovely everyday example of it all cooperating. A student finishes an essay in Word and clicks print. Word, the application, hands the document to the operating system, which passes it to the right printer driver. And that driver translates the pages into something the printer understands. Meanwhile, the operating system quietly manages the print queue so the student can carry on typing. And that's systems and application software working hand in hand. So why does all this matter to you? Once you understand the components, you can specify, upgrade, and troubleshoot a machine with real confidence instead of guessing. Knowing the two classes of software explains why a computer needs both an operating system and applications to be any use. These ideas run right through the rest of the unit, and employers and universities genuinely value someone who can use the correct words for things. Let's gather it all up. A computer system is hardware and software working together to input, process, store and output data. The key components are the CPU, RAM, motherboard, storage, GPU and PSU, and the processor keeps spinning through that fetch, decode, execute cycle. Software splits into systems, software and applications, and the operating system is the piece that manages the hardware and lets everything run safely together. That brings us to the end of the first outcome, where we've built a solid picture of what's inside a small computer system and the software that brings it to life. If you'd like to take it further, there's some genuinely readable material to explore, from Englander's book on computer hardware and systems software to the friendly explainers on BBC Bitesize and How to Geek. The professional bodies like BCS are well worth a look too, and the Raspberry Pi Foundation shows just how affordable computing has become. Have a browse of the reading listed here and see which parts spark your curiosity. And when you're ready, we'll move on to input and output devices.